Exploring Self-Assembly, a Nanobiotechnology Perspective.
Welcome to the Universal Principles podcast. Today we're diving into the fascinating world of self-assembly, where tiny components come together to build amazing structures. Think Legos, but on the nanoscale. To guide us through this, we have an expert in nanobiotechnology.
Thanks for having me. Nanobiotechnology is all about applying nanotechnology to biological systems. And what's fascinating about self-assembly is how it allows us to create complex functionalities from simple building blocks. It's like nature's way of creating order.
Could you explain that order from simple building blocks a little more? What's the higher-level concept at play here?
Absolutely. The higher concept is emergent order from local interactions. Imagine each component only interacts with its immediate neighbors, following simple rules. Yet, these local interactions give rise to a globally organized structure with new, emergent properties that none of the individual components possessed. It's magic, but it's science.
That's wild. So what are some real-world examples of self-assembly in nanobiotechnology?
One great example is DNA origami. We can design DNA strands that fold themselves into specific shapes, creating nanoscale scaffolds. These scaffolds can then be used to deliver drugs directly to cancer cells. Another example is self-assembled peptide nanotubes. These tiny tubes can encapsulate drugs, protecting them until they reach their target.
DNA origami sounds like science fiction, so molecules are literally folding themselves up. Is it only drug delivery?
Exactly, but DNA origami has other usages, such as the creation of nanoscale sensors and even tiny robots. Another use is the layer-by-layer assembly of thin films. We can deposit thin layers of different materials onto a surface, creating biosensors with specific properties to detect certain substances.
That's incredible. This principle seems so fundamental. Are there similar applications in completely different fields?
Definitely. Think about swarm intelligence, where simple agents interact locally to achieve a complex global goal. Like a colony of ants building a bridge or a flock of birds navigating together. It is also an emergent behavior from integrated complexity, which is currently seen in biodigital convergence.
Amazing, it is all connected. So for our listeners who are itching to apply this principle, what practical advice can you give them?
First, start by identifying the simplest building blocks needed for the desired functionality. Second, carefully design the local interactions between these components to drive self-assembly. Third, embrace the emergent properties. You might discover unexpected benefits from the resulting structure.
Great advice. It's all about understanding the pieces and letting them do their thing. Any final thoughts on the magic of self-assembly?
Just that observing this principle at work is a continuous source of inspiration. It shows us how complexity can arise from simplicity, and how understanding local interactions can lead to powerful, global outcomes.
Absolutely fascinating. Thanks for sharing your expertise with us. And thank you, listeners, for tuning into Universal Principles. We'll catch you next time as we explore another fundamental concept shaping our world.